Okay guys, so in this video we're going to be talking about finding the average rate of change. So the average rate of change in certain intervals. So these are some examples. So I should probably write average rate of change. That's the focus of these graphic samples. Otherwise, graphic samples don't really make much sense otherwise. So we're finding the slope or the average rate of change over the intervals. Now, for the intervals, it is very important to know that we're talking about the domain. So the domain is the input. So we're looking at always for these, we're looking at the x-axis. So the domain or the interval, it's talking about the x-axis. So now a lot of the times the reason why people get this wrong or get confused is because they start switching the x-axis and the y-axis and they start mixing them up. And then they get the wrong answer and they're wondering, why did I get the wrong answer? Well, basically, you're not looking at the domain. The domain is the x-axis. So I'm going to go ahead and just highlight the domain for you guys so you guys can see what we're looking at here. That way you don't make the mistake when you're doing this stuff on your own. So let's find the rate of change or the slope, basically, from 1 to 4. So look at where x equals 1, which I highlighted here. I'm going to go ahead and go up to the graph. I'm going to put a dot right there or a point, and then it's going to be all the way to x equals 4. Go to the graph. The function is going to be here. So what they're basically asking you is, what is the slope from this point to this point? Well, you have to count the number of spaces. How much do you go up or down? How much do you go over? So the slope is rise over run, right? So how much do we go down to get from here to there? And then how much do we go over? So if we count the number of spaces, we have to go down 1, 2, 3, 4, 5. So down 5, and then over to the right, 1, 2, 3. So my slope is down 5 over 3, or negative 5 over 3. Okay, so that is my average rate of change in interval 1 through 4. Now that being said, they could ask you any interval that they want, and you could find the slope based on those 2 points, depending on where the function is at. So I'm going to do a couple more examples for you guys. So the domain from 4 to 7. So from x equals 4 to x equals 7. Again, go to 4. We already have x equals 4 right there, so we're talking about this dot. Go to 7 on the function. Now for that function, we have to travel up a little higher. That's going to be where my function is at x equals 7. So what they're actually telling you now, so forget about this part, they're actually telling you what is the slope or the rate of change from this point to that point. So from x equals 4 to x equals 7. For that, instead of going down, now this time I have to go up a certain amount and then over a certain amount to get from one point to the other. The question is, how much do I go up? How much do I go over? So I have to go up 1, 2, 3, 4, and I have to go over 1, 2, 3 to get from this point to that point, right? So up 4 spaces to the right 3 spaces. So my slope from 4 to 7 is 4 over 3. Rise over run. Positive 4 because I went up, over to the right 3. Last one. I have to do the domain from 1 to 7. So from 1 to 7, I already have those points there, right? So from x equals 1 to x equals 7. Now notice that I'm not really using the 4 anymore, so just ignore it. I'm not really using that at all. So I'm looking at from x equals 1, which is that point over there, to x equals 7, which is right here. What is my rate of change? So how much do I go down? How much do I go over? Okay, so let's figure that out. So from this point to that point, I have to go down 1 space and then over to the right. Let's see, 1, 2, 3, 4, 5, 6. So I got to go down 1 to the right 6. I know it's kind of cluttered, but from this point to that point, so from 1 to 7, I have to go down 1 to the right 6. So the last example, from 1 to 7, it's down 1. So be careful, make sure you write your negative sign because we went down. Oh no, down 1, not 6. So down 1 to the right 6. So negative 1 over 6 is our final answer from 1 to 7. Okay, we'll do some more examples real quick because this is usually the part that people get freaked out about, to get confused. And then we'll be done with this video. So find the rate of change in intervals 1 through 6. So from 1 to 6. So go to the graph, domain, right? So we're looking at the x-axis. So from 1, follow the graph all the way up. the graph happens to hit up here. And then 6, this is the end of the graph. Follow the graph all the way up. And this is the point that they're talking about. So from 1 to 6, that's what we're trying to find. What is the slope? Well, to get from this point to that point, how much do you go up? If you notice, they're on the same level, right? They're actually on the same y equals 10 flat leveled space. So you really don't go up or down, right? You stay where you're at. So it's 0, and then over to the right, 1, 2, 3, 4, 5. So technically, if you want to write this as a slope, you don't go up or down, so it'll be 0 over 5, which is just 0. So when it's basically flat like that, when you don't go up or down, the slope is going to be 0 because it's going to remain flat. Okay, so that would be an example of a 0 slope for the average rate of change. Let's do one from 1 to 9. So from x equals 1 to x equals 9. So go back to the graph. X equals 1 is already up there. X equals 9 is going to be here. So follow the graph all the way to there. This is where the function is at. How much do you go, so from here to there, right? How much do we have to go down? How much do we have to go over? So in this case, we have to go down a certain amount. And we're going to have to go over a certain amount to get from this point to that point. All we have to do now is count spaces. So from 1 to 9, I have to go down 1, 2, 3, 4, 5, 6. So down 6. Over to the right, 1, 2, 3, 4, 5, 6, 7, 8. So to the right, 8. So from 1 to 9, my slope is down 6 over 8, which all you could do is simplify. This becomes negative 3 over 4. Okay, last example. So from 9 to 12. So what is the domain from 9 to 12? So from x equals 9 to x equals 12. Same thing. X equals 9 is going to be there at 4. X equals 12 is going to be here. Follow the graph all the way up. It looks like it's going to be right there at the tip of the arrow. So this graph goes forever and ever and ever, but we don't care about all that. We just care about from 9 to 12. So from here to there. So how much do we have to go up? Again, it's positive slope, so we have to go up a little bit, and we have to go over a little bit. We got to go up 1, 2, 3, 4, 5, and then over to the right, 1, 2, 3. So my rate of change is up 5 over 3 or 5 over 3. Notice that this is not a line, right? This is not a linear function by any means, right? So it goes up, up, and it goes forever and ever and ever. So since it's not a line, the slope is not going to be the same everywhere. That's why we have different slopes depending on the interval. So from 1 to 6, the slope was 0. From 1 to 9, the slope was negative 3 over 4, the average one. And then from 9 to 12, the slope is 5 over 3. So don't be freaked out if you guys get different slopes for every single interval that they give you. Okay, so I hope this video was helpful. I'll see you guys in the next one.